All right, cool. Welcome, everybody. So I'm Ethan. We're going to talk about event sourcing tonight. And my apologies if any of you were at the Utah.js meeting last month. The material covered here, we covered there as well, but there are a few changes. So I'm Ethan. I'm a freelancer. I live down in Provo, and I help companies make the transition to service-based architectures. And event sourcing is a big part of doing that well. But we're going to just talk about event sourcing today and not microservices in general. So if we're going to talk about event sourcing, let's talk about what it stands in contrast to. And that's what I'd call the traditional way of storing data. How many of you develop web apps for a living or for fun? Okay. Well, they store data probably. And the flow of it might look something like this. You have happy users. You have your application with a web server. There's some business logic, maybe a database. And for this discussion, we're going to be talking about this amazing application. Here, let me show it to you real quick. You see that? So you can create buttons and you can click them. I mean, that's just stellar. You want to run home and run that. But so a user comes in and they click that they want to create a button. And in this mythical app, they can supply a name for the button. And we're dealing in Node, so rec.body, that's very Express-like. You'd have a body of the request. In there is a name, and so you'd extract that information from the request, pass it to your business logic, and then it's going to stuff that into a database. So now over there in our buttons table, we have one row, ID 1, name foo. It hasn't been clicked yet. And we discard the user request. It's gone now. We don't look at it anymore. And with this information, then, we can render a nice response to the user, who then decides to click on it. And so this post to buttons one click. It has the button ID in there, goes through the business logic, updates our click count over there in the lower right, and the lightning bolt there is to draw attention to it. Maybe they click it a few more times, and it's great. And at every moment, we have the current state of the system. But maybe that's not so great. There's some implications of this. The first, again, is that the database is always just a snapshot of the current state of the system. We've lost all the history, and that might not be a good thing. We're reading and writing from the same data model. What do I mean by that? Well, relational databases are good at reading, and they're a little bit slower at writing. So why do we insist that our applications write to the same thing that they read from? Do we need to do that? What if, in addition to being able to just read a row out of a table, we want to see data in a different shape? Well, we can't do that in here because we just have this one way of storing it that represents the current state. And at any point, we're only storing what we're aware we need to store at that point in time. How many of you currently do, have before, or have a friend who's worked at a startup? Quite a few people. I spent a lot of time in the startup world, and one of the things we had was the need to do reporting. And we didn't really have a clear idea what reports we needed to do at the outset of a project. Reporting requirements could change very quickly. Even within the same day, you could end up with different reporting requirements. But if you didn't know you needed to be saving data for a report, how are you going to generate the new report? Well, you can't because you've thrown the data away. So then, what's the remedy to that? Event sourcing would be. Here is another web server with happy users, because that's very important. And that user, again, posts the buttons to create a button. But instead of feeding that into a relational database, we just write an event for what happened. So there is no buttons table in this system. We just make a record that a user created a button. And then maybe that button gets clicked. And so we store these count incremented events. And notice the stream IDs all correspond in these. We'll talk about why that's called stream ID. And so rather than taking the event, extracting it, stuffing it into a relational database, and discarding all that history, that is what we've actually stored for our app. Here's a question for you. Does that feel kind of weird? It is a very different way from the quote-unquote traditional way of storing data that we're used to. But that's okay. And also, there are probably some very obvious questions that come to mind, like, how would I take that data model and make a user interface out of it? But we'll get to that in just a minute. So let's define what we mean by events Especially with this being a Node.js meetup, we're probably very comfortable with the concept of events in general. For example, the FS module, you might do read file, and then it schedules an event saying, hey, your data's ready, or here's an error. And so I'm going to call that kind of an event a technology event or a technical event. And that is going to be in contrast to an interesting event in your application's domain. So to give a better example for that, imagine you're working for Amazon. Probably a core function of Amazon is taking orders from users. And so at some point when you order something from Amazon, you're going to click on a button that says submit order. I'm not sure what the actual wording is, but it doesn't matter. And that's going to have a technology event that a button was clicked. And that's important for the processing of the software. But that's not actually interesting to application's domain. What's interesting to Amazon is that user placed an order. So does that distinction make sense? Like, we're not caring about UI events or callbacks in Node. We're caring about like the actual business thing that occurred. So that's the kind of events we're actually going to be storing. And so that's what that's talking about. Then over here on the right is kind of a hypothetical structure for an event. Different event source systems will structure things differently. But the ones I put in bold, I would imagine you would find those in any event source system. So obviously they have to have types because you need to know how to respond to them correctly. The stream ID groups related events together. So, for example, if in our example when we create a button, we're going to start a new stream and give it a unique ID that's globally unique. And then all the click events are also going to have the same stream ID so that we know that that creation goes with those clicks. It doesn't necessarily always correspond to an entity in the system, in this case a button, or it might be a user, but it's just that these events are all related to one another. The stream version, that's useful in optimistic locking and concurrency stuff so you don't overwrite data. Payload, obviously you have to have what the event has in it, although some events don't necessarily have a payload. Come to think of it, created at just a basic timestamp. Okay, so the next part, this isn't actually pedantic, but it might seem that way. Event types are always past tense. And that's important because you really got to drive home the point. Events are things that have happened. You can't argue with them, just like past events in real life. They just are. There's no changing them. And so you would never see an event that's like, go order pizza. That would be a command. But you would see an event that's like, pizza ordered, pizza arrived, kind of a thing. And that event has been fired here tonight. So the stream ID again. Has also been fired. What was that? Pizza consumed is also been fired. Yeah, very happily. So the stream ID again is globally unique. So we don't want to, collisions there would be a very bad thing. And so the correlation ID, that's more of a kind of a debugging tool. Imagine for, if you will, you've got an Express server and you have a middleware in that Express server. Anytime a request comes in, it generates a new correlation ID, stuffs it in the request. That's now available to the rest of the request. Why would you need that? This is particularly useful in a distributed system. But if you do something, say publish an event, that has to communicate with another portion of your system, that correlation ID is going to go out with the event. Then if the things receiving those events in turn publish their own events, they would attach the same correlation ID to those. The reason for that is then, if you're debugging, I can see when user took action X, I can see everywhere else in the system that did something because of that. And so that's very, very useful for debugging. And so that's why that's in there. Any questions about the structure of the event? No? Okay. Cool. So let's come back to this question. How do we make a useful user interface? You could just dump all the events on the screen for your user and ask them to figure out that this means that there is one button that has been clicked 3 times. And if you're an auditor, you might really like that, but we are not all auditors. We'd like to see something more like this, which actually shows buttons with a nice click count under them. And so what we actually store in our system is this array of objects here. I've taken out some of the fields just so it would fit on the slide. But what we'd like to have is this single object over here that has keys corresponding to stream IDs and then contains the click counts. So let's put on our JavaScript hats. Let's put the JS in Node.js. Do we have a way in JavaScript where we can turn an array of things into a single thing?
Yeah.
What is it?
Into a single thing?
Yes.
I just thinking putting everything in a string.
Not quite. Reduce, exactly. That's exactly what we do here. I always forget to pop that question. That's the second time. I did that last one too. Okay. Greg Young is a guy who talks a lot about event sourcing and microservices, but he said that current state is a left fold of previous behaviors. Left fold is what reduce is called in functional programming circles. So it's just you have this stream of things that has happened, and then you just run reduce over it to get what the current state of things is. So let's go reduce some things, shall we? Here is an overview of the toy application we're going to be looking at. There's a browser connected to an API, and so this green box means that it's all in the same OS process, but send email technically is a service, which if you were at the thing last month, that would make a whole lot more sense, but we just in your mind right now, think of it as a separate component of the application. It is not coupled to the API, but it is actually running in the same OS process. And it's going to communicate with the API over events. And they're connected to not an Airstream, but an event stream. That one just gets lamer each time. All right, so let's look at some code here. I am really bad at typing code in front of people. I'm sure everyone else is just fantastic at it. But I'm not, so we're just going to look at some code here, and hopefully that's not a lame cop-out, but that's what we're going to do. Okay, so this application, I've posted a link to it in the slides too, and I'll share those, so if you want to go look at it later, you can. Basically, it's just an Express server, and I should probably make the text bigger. Is that better? And it's a GraphQL thing, but that doesn't matter. Just what we know is that when a user wants to go back to the app, if I click Create Button here, oh, that was really unfortunate. Did I not start my server? I didn't start my server. Okay, there we go. Haha, now it works. Okay, so I clicked Create Button. We see a button appeared. What's actually going on there? We are basically going to get dumped to this function right here, which is just going to punt to this actions create button up here. So this is what happens when someone actually clicks the create button. We're going to just make a plain old JavaScript object and call it button. We're going to give it an ID, and this is, any of you follow Eric Elliott? He wrote this CUID library, and that's way cooler than just using UUIDs, so that's why I'm using it. And so when a button is created, it has not been clicked yet, so we just set it to 0. Then this emit function, I'm going to ask your indulgence and do some hand waving here. Just understand what that function does is it takes an event and just puts it in the event stream. If you want to look at the mechanics of that, we can, but this is what actually publishes the event. And how you publish them, what they're stored in, is actually not particularly interesting to a high-level discussion of what event sourcing is. It's more of an implementation detail. But that's what it's doing. It's just taking this event that we've defined right here that has a type of button created, a stream ID that corresponds to that button's ID, and then a stream type of button. And then inside of this context object is where I've attached a correlation ID, so that's why that's going to emit. And it will return the button so that the client can make use of it and to display it on the screen. But, I mean, that's it. This request came in, emit an event, and that's all it does. In this fantastic app, we can also click buttons and their count increments. So when that happens, we have this click button function we eventually end up at that will have a button ID, and all that needs to do is emit an event again. This time, the type is count incremented, and same button ID, and also stream type of button, and context, and then that's all it does. Just emits that. And it does this get button function, which we'll look at in just a minute. Actually, why don't we look at it right now? Well, no, let's come back to it, sorry. Okay, so any questions on what that's doing? Is that pretty straightforward? Request comes in, emit some event related to it. Okay, sweet. So here's the interesting part. If I go back to the page and I reload it, we can see that the buttons show up again with the correct click counts. So how are we turning that stream into something? And here's where that magic happens. There's this roll-up function. Let me, go down one more place here. So I have this function buttons. This is what GraphQL will call into when someone requests all the buttons in the system. And that comes to, where to go, get button. So get button is going to do a couple of interesting things. This events queries all by stream ID is just kind of a helper function that goes to the event stream and says, hand me back all of the events you have that are of type button. And so that's what it's doing. And then we're going to pass that result into this rollup function. And here's where we start doing the reducing. When that's highlighted, it's harder to read, but that's the function. So it's just we're going to call events as an array. So we're going to call reduce on it. And let's look at what we're starting with first. It's this object that has a correct order array and an entities object. The reason for that is I want to hand back the buttons in the same order they were created. And so we'll see how that's used right here. So I've gotten all of the events in the system that are buttons, and I'm going to start going through them one by one, reducing them into this object here. So if I see a button created, I'm going to push that stream ID into the correct order array so that I have the correct ordering of the buttons. Then I'm going to create an object whose ID is the stream ID, and clicks are 0, and I'm going to stuff that into entities at the stream ID key. Following so far? Okay. And then I'm done with that event. I'm going to go on to the next one. If I saw a count incremented one, I'm just going to grab the corresponding button in entities and increment its clicks. And that's all. That's the whole reduction right there that allows me to generate, what this wants to see. The one thing is now then I have that correct order, so I want to go through those IDs and extract the buttons for them and hand back an array of buttons. But I mean, that's it. That function right there is the whole thing that turns that stream of events into useful user interface. Any questions about that? Yeah.
On the correct order, you're just sort of assuming that your event storage can maintain the correct order.
That's right. And it's a super important part of it. It's good to bring it up. It's very critical that events get processed in the same order they were emitted. Otherwise, you might see a weird thing like deletion of something happening before its creation. And that gets you into a weird indeterminate state. So it's absolutely critical that things that will be processing events get them in the same order that they happened. In this app, I'm using an SQLite database under the hood. So the primary key, the ID column in the table manages that. But in other things designed for event storage, they would have their way of doing it. The timestamp can be used for that, but millisecond resolution makes me kind of uncomfortable for that. I'd like the nice auto-incrementing ID.
Especially when you're going across systems and your engine may not be that
Yeah. Wait, I thought computers always had the same value for their clock. Because they're close to each other. No, just, yeah, but that's a huge thing. The events have to be processed in the same order that they were received for the same stream. Let's just leave it, they should all be processed in the same order, and I'll think through any greater implications of that. Okay, so this app though, which is amazing, has this other great feature, send email, because if you create a button, you want to know when it's been clicked, right? Because if you create your button and no one clicks it, that's kind of sad. So this also has a send email functionality in it. Now let's look at that real quick. And you can even see this in action. Let's do this thing. So every 10 seconds it checks for send, so I need to be quick. I'll click this one. It only sends it on the first time a button got clicked. And within a few more seconds, boom, look at that. It sent an email for the button with that ID. That's great, isn't it? Let's look at how that happened. And this is an example, while we're not specifically focusing on microservices right now, it shows where event sourcing is really nice for dealing with microservices. This little module here has this tick function, which will check to see if it needs to send something, and we'll see how it determines that. And then once it's done that, it will set a timeout for itself in 10 seconds. And then we just kick it off when the Node app starts. And that's why over here in the terminal, these check for sends are showing there, because I wanted to see some output to make sure it was happening. So in tick, it calls check for send, and here's that function. It's going to just generate its own correlation ID, which is email check. This probably isn't going to trigger anything else in the system, but just in case, it'd be nice to know what triggered certain events that we see. It's again going to use that all by stream type function because it's interested in buttons. Once it gets those, it's going to feed that into, get buttons needing email, which serves the same purpose as the roll-up in the other file we looked at. And so it's the same thing. It's going to get a list of events. This one happens to not care about the order of them because it just doesn't matter. But this time, when an event comes in, for example, when it is checking the button created, notice what it creates. It just creates a plain old object with an ID of the stream ID, not a click count. It doesn't care about the click count. So it's a different view of the same thing for this different service. And that's one of the key strengths that we'll talk about in just a minute too. But if it sees a count incremented for the button, it's going to check to see if this needs email flag has been defined. And if it has not been defined, it will set it to true. And then it'll set the correlation ID from the event that it received. So when I go and I click a button, my request that click that button is going to have its own correlation ID that gets stuffed in the event. When the email service picks that up, it's going to use that same one from my request and store it for a minute. And then if we come across one that says email sent for a particular button, we're going to say, oh, just kidding, we've already sent it for that button. We don't need to send it again. So this function here is just trying to identify the buttons that have been clicked for the first time and we haven't sent an email for them. And then at the very bottom, we filter out, making sure we only get the ones that have not seen an email yet. And so armed with that list of buttons, we send them into this function, which if we didn't get any, just move on. And if we did, we're just going to build up this promise chain, so it will send the emails one at a time and call this send email for button. That function is right here, but again, not particularly interesting for what we're talking about tonight. So any buttons that have been clicked, but we haven't sent an email for them, we send the email, then we're done, and then we schedule ourselves to run again in 10 seconds. Does that make sense? Okay, cool. So, whoops, let me put this back on. So what's really neat, what we saw out of this was we have different views of the same state, right? The thing that sends emails, what a button is, means something different to it than what the UI thinks is a button. It's less apparent in this because, it's just buttons, they're so similar, but I had this great example earlier today and I just forgot it. But I mean, you might be able to imagine scenarios where you could take a user, for example. Maybe if you're populating a user profile screen in an application, what means a user is different than, say, when you're exploring connections between users. Because on a user profile screen, what is a user? It's a collection of like name, email address, preferences for sending emails. But if you're exploring like Facebook social graph, then a user is something that has connections to other of the same type of somethings. And so with the event source model, we're able to build both of those representations from the same source data. And then if a third requirement comes along, we can build that third requirement as well. And so what we saw in our thing was that was our stream of data. So for sending it to the client, we built this simple object with an ID and a click count. But for dealing with emails, we had these other things we needed to worry about. And so, I mean, honest to goodness, the sky is the limit with that. In a system using event sourcing, you're not limited to just, oh, I've got the database where I can read things from. From the same stream of data, you can make simple tables for populating user profiles. You can use the same data, populate a graph database for exploring connections between things. Really, if you have reports to generate, you've got all the source data, you can just generate whatever specific reports you want, and you haven't lost the ability to do that. So one thing I want to hit, we didn't hit this last month, was that an event source system is not an event stream. In my application, I happen to model it as a single table in an SQLite database, but it's actually conceptually, it's multiple streams. So again, the app happened to put it in the same table. So the streams, if we go back up to the event definition, are identified by the stream ID. And so this is just a point here. They don't necessarily correspond to single entities in the same system. In this app, that happened to be the case. When you resolved the stream, you were looking at a button. But you can imagine a bank account. Transactions on an account would probably belong in the same stream as the account. Like you wouldn't create a separate stream for a transaction. But it might be that transactions are entities in their own right. You might want to look specifically at a transaction and see the details on it, but really it would be part of an account stream. Does that make sense? Is that a decent example of why?
Why wouldn't you just use the account ID?
So the account ID will be pulled from the stream ID, but just trying to, not great at explaining this, but just you don't want to get into your head that stream corresponds to single entity, essentially. Does that help at all? Okay.
Having it decoupled is good.
Yeah, so it may very well be the case that the stream is an entity. It could be, but it's not limited to just that. In Amazon's ordering process, for example, the stream of events corresponding to an order is going to have things like that the user placed the order, but before that it might have items added to a shopping cart. And so you might have a stream that starts with an item getting added to it, maybe 3 more items, something gets deleted, an order was placed on that shopping cart, shipping information was attached to it, and all these different things might be entities in their own right, but they all are related to one another still. So hopefully that example is a little bit better than the bank one. And then lastly, you probably wouldn't want to roll up all these events on the fly. It worked great for this simple app because there aren't a whole lot of buttons, there aren't a whole lot of clicks. But that, on a really large database, that could get kind of slow. And so one thing that's really powerful to do with this is as the events are happening, you can be instantly projecting them into whatever you're going to read them out of. So with the button clicks example, instead of loading all the events and then reducing them on the fly, I might have something that observes the events coming in, and when it sees created, it's like, oh, shove that into a database table. When it sees a click event, it says, oh, I'm just going to update that count. And so then when the UI wants to read the buttons back, it just reads that already projected list of things rather than loading all of the events and reducing over them on the fly. And then this last point here, you might see this and think, okay, Ethan, you said a lot of things about like, oh, reports you might want to generate, but you don't know you're going to, so doesn't that fall under you ain't going to need it? But here's the important question. If you're building an app and you've done the model where request comes in, extract the data, toss the event away, when you made the decision to do that, was it a conscious decision where you sat down with the business team at the place where you work and you said, look, here's a list of reports you've asked for, we're collecting that data, we don't think there's any value in the rest of it, and it's kind of annoying trying to store it, so we're just going to go ahead and pitch it, and then the business people said, you know what, that's a good thing, let's go ahead and do that. Is that the discussion that actually happens, or is it just like, oh, I've just always done apps this way, so I'm just going to pitch all the data? So I would counter you ain't going to need it with you're doing a premature optimization, because the only reason to pitch that is, oh, well, we're not going to need the data, that's optimization. How do you know you're not going to need it? And you're actually doing extra work to throw it away, I would say. So some additional resources. There is obviously the code to this great app. Some people to follow, Scott Bellware, Nathan Ladd, really smart people. They're worth following on Twitter. And I made this pitch last month. I'll make it again. If event sourcing and microservices, that kind of stuff interests you, if it's useful to you, those two guys, they do a workshop at various places around the country, but they need a critical mass of people willing to attend it. And I would really like to attend it without flying out to someplace else. So if this would have use for your business or your own edification, please come talk to me so we can say, hey, we've got enough people, come do one out here. So that would be great. Greg Young, he's a good source on it. And then we didn't actually talk about CQRS. We did, we just didn't name it. The idea that you could write in one way, read it out in different forms, that's what CQRS is, and that's a nice video about it. And that's all. Any questions?